There's a lot of concern around the ways in which all of these different systems interact and the ways in which that interaction can possibly form a source of vulnerability. But one of the key concerns is just the massive amount of computing power that it takes to train and operate and simply use these models. They use a ton of water, they use a ton of energy, they take up a lot of space because you need these big server farms, and that comes with tremendous expense. There are only a very small number of companies out there that actually have the resources to be able to do this regularly. So that small number of companies basically gets a big say over what gets into the design and what sorts of designs get implemented. Another major concern anytime you're using a lot of energy is just the amount of heat generated by that energy. That's been linked to things like water quality. In the event of a major natural disaster that maybe knocks out that power infrastructure for a while, the question then becomes, will that actually knock out some of the computing infrastructure? And what are the consequences there for our ability to keep society running if society is relying on this deep computation in order to do critical functions? A large part of what we're trying to do on our systems engineering side here is to really understand the role that governance strategies can put in place, safeguards against these sorts of cascading issues. It's about the ways in which the AI interacts with other systems, the way that that interacts with our governance strategies, the way that that interacts with specific types of users, really the entire spectrum of the engineering development lifecycle.